when we're doing these proofs, always look for the given. So see that statement, I know that statement is true because it's given. And then this is the other statement. I know that statement is true also because it's given. Okay? And then I'm just going to put these marks on my diagram. That way we can figure out why the two triangles are congruent, BC. So parallel, remember parallel is just like an arrow. So I know this line is parallel to this line. And then BD congruent to DB. Well, here's BD, and this one is DB. It's actually the same line, so this is going to be the reflexive property. Again, I like to call it the shared. It's a shared side, or the same side, right? And the reason why it's written backwards and not necessarily in the same direction, if you look up here at the congruent statement, they're backwards, right? BD and DB. Even though it's the same two letters, they're switched. And that's because these two triangles are actually flip-flop. Okay? And then the fourth statement says CBD. And then again, you have to be able to find that. If you follow the letters, it goes CBD. It's this angle up here is congruent to ADB, to this angle down here. Okay? And then, long story short, whenever you see one line parallel to another one, you should always think, hey, alternate interior angles. Okay? Remember when we had alternate interior angles, alternate exterior angles, corresponding angles. These ones need to be inside the triangles though, so they would be alternate interior, not exterior. Okay. And then if we look at our markings, we have, oh, I didn't put the shared side in there. Here's the shared side. We have angle, angle, side. And that's the proof. Okay. Let's move on to the next one real quick. Again, BAC. BAC is here. And that's congruent to DAC. How do we know that? It's given. And then BA is congruent to DA. BA congruent to DA. How do I know that? It's given. And then AC is congruent to AC. How do I know that? It's the reflexive property. Or same side. It's the shared side. And then the last one, if you look at the markings, side, angle, side. Side, angle, side. And we're done. Not too bad. My paper looks crooked. And then the last one, let's do the last one. So if you look at this, AB and BC, here's AB, here's BC. I know those two sides are congruent because it's given. And then DB is the angle bisector of triangle ABC. So BD, well here, I know that is true because it's given. Okay, I know that's true because that's given. And we have to remember, see, DB is this line segment here. We have to remember what it means to be an angle bisector. So they're saying it's an angle bisector of angle ABC. Angle bisector means it cuts the angle in half, or into two equal parts, two equal pieces. So that means I know this angle is congruent to that angle. That's the definition of angle bisector. And that's the reason I know these angles are congruent, which are these two that I just marked out. Definition of angle bisector. And then this one, well, If you haven't figured out its reflexive property yet, if you look at the diagram, you can tell it's a shared side, which is reflexive. Right? BD is congruent to BD. And then finally, if you look at the diagram, you can figure out the congruence conjecture, or the shortcut. I know this triangle, ABD, is congruent to this triangle, CBD, by side, angle, side. Right? This is a side congruent to this side, this is an angle congruent to that angle, and this is a side congruent to that side. You have side, angle, side on both triangles.